Hi, my name is Ivana Robledo, and today I'm presenting the final stage for my key activity for Physics 2. Um, well, for my key activity, I decided to go with a project based on projectile motion, which can be defined as the motion of an object thrown into the air, being only affected by the acceleration of gravity. There are two independent rectilinear motions along the x-axis and along the y-axis. Due to the fact that there is no acceleration in the horizontal direction, its its velocity remains constant the whole time and the whole trajectory. The time it takes for the object to complete the path of the horizontal range, which is the distance between the point of projection and its final position, it's called time of flight. And well, with my practice, I intend to understand the projectile motion of an object and its multiple applications, because on a daily life basis, projectile motion can be frequently observed in sports, such as when someone kicks or throws a ball. Um, Even when we're at home, when we do certain things, we throw the keys to our parents or something like that, we can see projectile motion, and it's a pretty interesting phenomenon. As we can see in the image here, well, there is the x range and the y axis, which are the rectilinear motions that can be seen in projectile motion, and this is the range, and here this whole path is the time of flight. So yeah, well, my variables and the experimental arrangement for the experiment. The variables are two independent and two dependent variables. The independent ones are distance and acceleration, which never change, are not affected by the other variables. And the dependent ones are the time and the velocity of the object, the time the object takes to travel its whole path, and the velocity it has when it does. Now, the experimental arrangement consists of a plastic tube cut in half, which is used as a ramp, a ball, an Apple Watch to measure the time, a stack of books, and a table, and a measuring tape to measure the length from which the ball will be released. And this heights and lengths will change the slope, and therefore it will affect the initial velocity the object has. This is the experimental arrangement: the ball, the plastic tube cut in half, the measure tape, the Apple Watch, the stack of books, and the table. Well, the materials, here they are. And the methodology, well, I cleared this formula for chi, and then these with these times that I cleared for, with the different distances and all of that, I used the general formula to have the other results. I substituted the different height and velocities to get the results. The stack of books of a height of 0.09 meters was placed in the table 0.45 meters away, so 45 centimeters away from the edge of the table, which the table's height was 0.35 meters. The half of the plastic tube, which its length was 0.35 meters, was attached to the stack of books, and the ball was dropped from this height into the ramp, and the time it takes to reach the table was recorded, and the initial velocity was calculated with the length and the time it took to reach the table. And then the height of the stack was increased, and the same process was repeated 4 times. These were the results for the experiment and for the theoretical results. The first table, the first column it belongs to the different heights of the stack of books from where the ball was released. And the second column, where the resulting velocities came from the increasing slopes of the stack of books in the ramp. The second table, where the first column belongs to the different initial velocities of the ball when it was released, and the second column is the experimental resulting time it took to reach the ground. So the actual time it took to reach, to complete its time of flight with the experiment. And table number 3, well, it's the same. The first column belongs to the velocities the ball had when supposedly released, and the second column is the theoretical resulting time. So this is the time I got from the substitution with the formula. Well, in conclusion, I practiced this experiment to have a better grasp of this topic because I think it's a topic that actually we can see a lot in a daily basis, and it's not so weird to experiment. And the height and the slope at which the ball is released does affect the time it takes for it to reach the ground. My whole objectives were met, and the hypothesis that the steeper the slope, the less time it takes to reach the ground was proved because of its initial velocity. Its initial velocity was obviously affected by the slope, and it reduced the time it took to reach the ground. So thank you very much, and good afternoon.